Okay, before I go into the math of what we're trying to do, I wanted to take the time to generally explain what it is that we're trying to do. So, going back to the rocket that we shot, the path looks something basically like this. So this is the point that we shot it from, and this is where it landed. So if we were going to think about that and kind of a 3D terms, we would say that this was the x-axis and this was the z-axis, where the z is the height, and just we'll say that it didn't shift any direction in the y. It stayed straight true on the x-axis. So if we were going to draw that in 3D, we would say this is the z-axis, this is the x-axis, and this is the y-axis. So in 3 dimensions, the rocket would have looked something like this. It would have started here, gone up, and come back down. So what we're trying to do is say that we had some command center located in the XY plane. So imagine this is the XY plane here. So imagine that we took this XY plane and just pushed it over backwards, and it fell flat just like this right here in the 3D. And some distance away from where the rocket launch was, we were set up there. We'll call that distance R. And it was some angle away from where we started, right here, from where the rocket was shot. So if we draw that in 3D, it would look something like this. Okay. So we're set up over here, and what we want to do is we want to shoot a missile of our own to intercept and knock this rocket out of the air before it touches the ground below. So that's the general idea of what we're going to try to do.